In today's video, I am going to discuss about the method of solving some problems related to calendar. Obviously, this is not a part of higher mathematics, but some of my students told me to make a video on this topic because this topic is extremely important for different government examination. That's why I am making this one. So let us start with the basic criteria. As you can see, we all know that years can be classified into two major parts. Obviously, first one is ordinary year and the second one is leap year. Now, simply ordinary years interprets that you have 365 days in it, and obviously in case of leap year, obviously an additional day will be included. So that means 366 days. So whenever we want to consider the problem of different problems related to calendar, first of all you have to know the idea of odd day. This part is very important. As you can see, I have also written the concept of odd day is very important. Now how to determine how many odd days are there? Simply you are given a number of days, for example 200, 300, 365, etc. divided by 7. What will be the remainder? That will be considered as your odd day. For example, if I consider 365 days, we all know in a year it will be 365 days. So if I want to find out how many odd days are here, odd days in a year, then simply we can divide this entire expression by 7. As you can see, I have written 7 into 52 plus 1. That means if you divide it by 7, you will get 52 as quotient plus 1 as remainder. So that means you have 52 weeks in a year, and as usual one remainder or additional day. So that means this is the remainder whenever you are dividing it by 7. So number of odd days in an ordinary year will be 1. Similarly, in case of leap year also we can assign the same thing like this. It will be 366 days divided by 7. So technically you can write 366 as what? 7 into 52 plus 2. That means 2 odd days will be there. So simple thing is that given a certain number of days divided by 7, whatever may be the outcome in terms of remainder, that will give you the idea of odd day. Now if I want to consider how many odd days are in 100 years, now one thing you should be very careful about this fact. Whenever there are centuries 100, 200, 300, 400, etc., in order to say that is a leap year, it is not sufficient that you have to divide it by 4. We all know how to identify a leap year. Simply the year should be divisible by 4. But in case of centuries, the situation is little bit different. It is not only divisible by 4, but also it has to be divisible by 400 as per Gregorian calendar. So 100 is not a leap year, although it is divisible by 4, but technically it is not divisible by 400. Similarly 200, 300, these are not leap years, but whenever you are considering 400, it is definitely a leap year. Similarly, if I ask you whether 2100 is a leap year or not, the answer will be no, it is not a leap year, because it is divisible by 4, but it is not divisible by 400. Okay, but for all other years except centuries, you can consider the divisibility in terms of 4, whenever we have to check whether it is a leap year or not. So whenever we want to find out how many odd days are there in 100 years, simply we can proceed in this way. If we divide it by 400, then why we are dividing it by 4? This is the main question, because after a span of 4 years you can expect a leap year will be there. So that means first leap year will be 4, second leap year will be 8, third leap year will be 12, and so on. In this way you can carry on. But if you proceed like this, 4, then 8, then 12, then 16, and so on, you can carry up to 96, because 100 is not a leap year, as I have mentioned earlier. So technically divided by 4, then you will get 25, but one leap year cannot be included. That means actually you can have 24 leap years in 100 years, but all other remaining, that means 100 minus 24, that will be 76. So it will give you only the concept of ordinary year. So we can say in a century there will be 24 leap years and 76 ordinary years. Now already we have seen in case of any ordinary year how many odd days are there? Obviously 1. So in 76 years, number of odd days will be what? 76 into 1. Similarly, in a leap year, how many odd days are there? 2 days. So in 24 leap years, number of odd days will be, odd days will be 24 into 2. So 76 plus 48, that will be 124 odd days. But again, you cannot carry on with this larger number. Simply you have to divide it by 7. So that's why you can see I have written 7 into 17, that is 119, plus 5. That means remainder whenever you want to divide this quantity by 7 is nothing but 5. So in case of 100 years, you will get 5 odd days. This concept is very important for solving different problems. Now if I ask you how many odd days are in 200 years, so whenever in 100 years you have obtained already 5 odd days are there, in 200 years it will be doubled. That means you can say 2 into 5, that means 10 odd days will be there, but practically you cannot say it is 10. Whenever you are getting a number which is larger than 7 or at least it is equal to 7, simply divide it by 7. So if I want to divide it by 7, then 3 will be the remainder. So in this case you can say number of odd days will be 3, not 10. So in this way we can carry on. So you can see I have also mentioned this thing, that in 200 years number of odd days will be 2 into 5, that is equal to 7. So 3 odd days will be there. Similarly in case of 300 years it will be what? In each 100 years we have number of odd days equal to 5. So in 300 years it will be 3 into 5, that is 15, divided by 7, then you will get 1 as remainder. So technically 1 odd day will be there. Now the interesting fact is that moving on to the 400 years, it will be 4 into 5, that is for 20, but 400 itself is a leap year, so you can consider 21, that means 4 into 5 plus 1, this is a leap century. So in this case you can see if you divide it by 7 you will get number of odd days equal to 0. So consequently in 500, in 600, in 700 you can easily find out how many odd days are there. Now you can see I have written here in terms of a note, every year divisible by 4 is a leap year if it is not a century. That means in this rule is applicable only for non-century years. That means you cannot apply this one, the concept of divisibility, for 100, 200, 300, etc. etc. 100 is divisible by 4, but it is not divisible by 400. That's why you cannot say it is a leap year. Similarly in the second note you can see I have written every 4th century is a leap year. That means 4th century implies 400, 800, 1200, 1600 to 2000 and so on. But no other century can behave like a leap year. So these two facts are very important also. Now here I have given a chart for your convenience. You can see I have listed all possible months, also their respective days and number of odd days, and also I have given the idea how to determine the odd days. Simply divide the total number of days by 7. In case of January it is 31 days, so technically divide it by 7, 4 7s are 28, remainder will be 3, so number of odd days will be 3. In case of February, 28 days are available, obviously we are considering a non-leap year, so technically number of odd days will be 0. Similarly in case of March, in case of April, May, June, July, August, September, October, November, December, everywhere you can see I have written in this chart number of odd days equal to like this. Just simply remember how many days are in that month and simply divide it by 7, then you will get the idea of odd day. Now the next important thing, there is another chart which shows the relation between odd day number and the day which will be assigned corresponding to number of odd days. Suppose you are getting odd day is equal to 1, then assign Monday to that particular odd day. If the odd day number of odd days is equal to 2, always remember the day corresponding to it will be Tuesday. Similarly for 3, 4, 5, 6 you can see the day corresponding to this 3, 4, 5, 6 number of odd days will be Wednesday, Thursday, Friday, Saturday respectively. And the last one, whenever you are getting number of odd days is equal to 0 or 7, because 7 is also divisible by 7 itself, so remainder will be 0. That's why I have given 7 or 0. So in that case you have to assign Sunday corresponding to that odd day. Now there are several types of problem, but in this video I am going to discuss about 2 specific types of problem. A certain day or date will be given to you and you have to find out the day, and also I have shown another problem where you can find out the back date. So first let us start with this problem. We are trying to find out the day of 15th August 1947. So first identify which one is the nearest century or leap year or something like that. 1947, consider this one as what, 1900, because this is the nearest century. Then plus 46 plus period of 1147 to 1547. Why I have split this one? Because you are not considering the entire year of 1947. You have to consider from 1st January to 15th August. That's why period of 1147 to 1547. And also 1900 years plus 46 years already which has surpassed. That's why I have to write in this fashion. Now remember, in 400 years how many odd days are there? I told you it will be what? 0. Just in the previous page we have seen this one, previous part. In 400 years number of odd days will be 0. So just in 800 years again the number of odd days will be 0. Why? Because 800 is also divisible by 4 as well as 400. Then in 1200 it will have the same criteria and so on. So here in this way, whenever you are considering 1600 years, number of odd days will be 0. Then number of odd days in 300 years, already we have expressed, in 300 years number of odd days will be 1. So technically you can see in 300 years we can say number of odd days will be 1. Now in 46 years, first divided by 4, identify how many leap years will be there. 46 divided by 4, if you divide it you will get 4 ones are 4 and this one. So technically you will see 11 leap years will be there. That's why in 46 years we can say 11 leap years are there, plus remaining 46 minus 11, that is 35 ordinary years will be there. Now in each leap year we know 2 odd days are there, so 11 into 2, for each and every ordinary year only one day will be there, obviously that is odd day, so 35 into 1. So total number of odd days will be what? 11 into 2 plus 35 into 1, that means 57 days. But from 1st January 1947 to 15th August 1947, again if you want to find out the number of odd days, simply assign the months. In case of January, how many odd days are there? We know 31 days are there in January, so divide it by 7, you will get 3 as remainder, so 3 odd days. In case of February, for 28 days, divide it by 7, you will get 0 odd days. Similarly for March, April, May, June, July, you will get all possible odd days. Now technically I have calculated up to July, because even we are not considering the entire month of August, we need to consider up to 15th August. So 1st August to 15th August, how many days? 15 days. Divided by 7, how many odd days will be there? Only 1 odd day, because 15 divided by 7 will give you only 1 as remainder. So now in 1600 years number of odd days will be 0, in 300 years number of odd days will be 1, in 46 years number of odd days will be 57. You can say this is number of odd days. So 0 plus 1 plus 57. Then in January 3, in March 3, April 2, May 3, June 2, July 3. That means 3 plus 2 5, 5 plus 3 8, 8 plus 2 10, 10 plus 3 13, plus 0 13, plus 3 16. So plus 16 and plus 1 odd days. Just simply calculate all this. So 57 plus 1 58, plus 1 59, plus 16, 75 odd days will be there. Now again, because this is greater than 7, so whenever you are getting any value which is larger than 7 or at least equal to 7, divide it by 7. So simply you will get 7 into 10 plus 5, that means you have 5 odd days. So technically you can say 15th August 1947 will be what? 5 odd days. Remember the chart. Whenever you are getting number of odd days equal to 5, assign Friday corresponding to that odd day. So that means definitely 15th August 1947 was nothing but Friday. You can Google it to verify the result. Okay, just type this date, you will see whether it is Friday or something else. So in this fashion you can solve this type of problems. Now another type of problem can be solved. Now here you can see I have given 2 additional problems so that you can practice this type of structures. Now in type 2 we have to go in the backward direction. Suppose 6th March 2005 is Monday, then what was the day of 6th March 2004? That means we are doing back calculation in this type of problems. Now February 2004, you need not to consider this one, but still I have written this one because remember February 2004 is supposed to be what? A leap year. But here we are not considering February because we have to consider only March. So we consider March 2004 to March 2005. So technically 6th March of 2004 to 6th March of 2005, it is equivalent to 1 ordinary year. That means 365 days. 365 days in an ordinary year, we all know number of odd days will be 1. So here you can say whenever odd day is 1, simply the day which will be assigned to that odd day, that is nothing but Monday. So 6th March 2005 is actually Monday, and hence 6th March 2004. Because you are moving in the backward direction, so required date will be just the day which is previous to Monday. So technically it will be previous day of Monday, that is nothing but Sunday. So simply you can remember it is one day before that of the original day. So whenever you are considering back calculation, depending on the number of odd days, you have to move in the backward direction. Suppose there are 2 odd days, suppose in any problem, then if the original day is Monday, then the required day will be what? Just 2 days before it will be what? Saturday, because before Monday it was Sunday, then it was Saturday. So technically then the result will be Saturday. Here we have obtained only 1 odd day, that's why you can say the required day will be Sunday, one day before that of Monday. Also you can see I have given another example. 26th January 2020 is Sunday. What will be the result corresponding to 26th January 1950? So how many years already lapsed? You can see 2020 minus 1950, 70 years already spanned in this part. So technically divided by 4, then you will get 70 divided by 4, 417, 68. So 17 leap years are already included in it. Okay, so whenever you are considering 17 leap years already included in it, so technically identify how many odd days are there. Now one thing you must not forget, technically 2000 is already included in this span, so it is in multiple of 400. So that's why we can consider it is divisible by 4 as well as 400. So in this case you can say it will be a leap year. Now because you are considering back calculation, the process is little bit different. Already 70 years are there and 17 leap years are there. In case of back calculation, you have to add these two quantities, not subtract. So 70 plus 17, that means 87 already, which includes 2000 because it is divisible by 404. But whenever we are moving in the forward direction, we have to consider leap years and non-leap years, that is ordinary years, in a separate manner. But whenever we are doing back calculation, it is convenient to consider the total number of years as well as the leap years altogether. So 70 years altogether, but 17 leap years are included in this 70 years. So that's why 70 plus 17. And again I am saying 2000 is already included in this calculation. So simply you have obtained 87. Just add all this, divided by 7, then you will get what? 7. Whenever it divides 87, 7 ones are 7, 7 twos are 14. That means 3 odd days are there. That's why I have written ultimately you will get 3 odd days. So technically 3 odd days means what? You have to move in the backward direction. How many days? 3 days back. So initially it was Sunday, so its previous day will be Saturday. Then one step before it was Friday. Then one step before it was Thursday. So technically if you consider 26 January 1950, it must be Sunday minus 3 days back. That will be nothing but Thursday. So this is the criteria, or this is the technique by means of which you can solve it rather easily. So here I have discussed only 2 types of problems related to calendar. If you require more, you can comment in the comment section, and I hope this video will be beneficial for your upcoming examinations. Thank you.